Okay, so if you're watching this and it's Wednesday night, you can go ahead and stop it. This is actually for class during Thursday. I thought I'd make this real quick before I went to bed because I'm not really feeling that good. So I'm not going to go tomorrow. I don't think it's Cheez-It related, so I don't blame you, Rachel, yet. But if I die or something, you might be a little worried. So here we go. Let's see here. Basically, I'm just going to keep doing more substitution stuff, but they're going to get a little harder. So I'm just going to do a few examples and then give you some problems to attempt. Hopefully after last night's 4 problems, you're catching on a little bit. A couple of these, though, these are hard. So I'm going to try this whole holding the camera thing. You guys will have to let me know which way is better. I'm just trying to get it closer to where you can actually see the writing. Alright, so here's another one. Yeah, I'm trying to look through the iPad again. It's not working. I have to change it a little bit. So there's our problem. And on these, they're not going to tell you what to use for you. You just got to figure it out yourself. And the way to figure that out is, I don't want to say guess and check, but kind of. I mean, looking at this one, it should be pretty easy to see. If you let u be the tangent of x, then that'll get rid of this. Because I don't know what the antiderivative of the square root of tangent of x is. I know what the antiderivative of this part is, so if I could somehow take care of that, it might help. So basically you're just going to have to try things here. So, I need to adjust so I can actually see what I'm writing. Let u equal the tangent of x. When I do that, the square root of u times secant square root of x dx. That's still ugly, but let's see what happens when I do du here. Du will equal secant square root of x dx. And hey, look at that. Secant square root of x dx, that's secant square root of x dx. So that should tell you right away that's square root of u du. And it should be easy from there. Alright, that's u to the 1/2. So, integrate that. You'll have u to the 3/2, so what is that, 2/3? U to the 3/2 plus c. Plugging u in, be 2/3 tangent of x to the 3/2. So I'll just click that. Plus c. So that one wasn't that bad. One that I was trying though that was hard was like this. So looking at that, first thing I thought was to try and let u equal x over 2. When you do that, you have tangent to the 7th of u, secant squared of u dx. Figuring out du, x over 2 would just be 1/2 dx. So there's nothing that matches over there. So if I multiply both sides by 2, I have 2 du equals dx. So I can plug that in. So I have 2 tangent of 7u secant squared of u dx. Got there and was like, well, what's the antiderivative of that? I have no idea. So that didn't work. So I gotta try something else for you. Basically, I would just start small and kind of work out bigger. So I was thinking, what if I let u equal the tangent of x over 2? Well, now, if I do this, plug in tangent x over 2, or plug in u for tangent of x over 2, so I have, this is really hard to do this with this camera. There we go, maybe that'll work. U to the 7th, secant squared of x over 2 dx. Well, that's nice. Hopefully, I know the antiderivative of secant squared, so maybe this will work out. So if I do the derivative of this, that's du equals derivative of tangent is secant squared of x over 2. But I need chain rule, so the derivative of the inside is 1/2, so it's actually 1/2 secant squared of x over 2 dx. Solving for dx, multiply both sides by 2, so I have 2 du equals secant squared of x over 2 dx. Divide both sides by secant squared of x over 2. And so that's what dx equals. So we plug that in there. And so secant squared of x over 2 on bottom, and then that one, those are going to cancel out. So really I'm just going to have 2u to the 7th du. Hopefully you can see. Didn't really show my work there. If you want to, go ahead and write that in that's place, and then you'll see that those will drop out, and you'll just have u to the 7th times 2 du. And then, again, once you get to that point, it's easy. Do the antiderivative of that, so that would be what? U to the 8th. 8 times what gives me 2 1/4 plus c, and then plug your u back in. So it would be 1/4 times the tangent of x over 2 to the 8th plus c. And you can write that 8th power right there, or tangent to the 8th, it doesn't matter. So that's, when you first look at them, it's horrible. I agree. Show you one more how you might have to change something. Let's see. Dx over sine squared of 3x. So something like that. I changed this. First thing I did here was rewrite it as 1 over sine squared of 3x dx. You don't always have to do that, but like we saw in that one from last night's homework, that you don't have to, but sometimes it helps. And the reason I know this helps is because I see 1 over sine squared. And you may not remember these, but that's a trig identity. And over on my printer, I printed off a bunch of them yesterday, so hopefully they're still sitting there. I don't know. But I printed off some stuff with all the trig identities on it, so you can look at them and try to remember them from when we went over them last year. Because it's looking like it's unavoidable at this point. We need to remember them. The reason I say that is because to do this one, you change 1 over sine squared. Well, that's cosecant. So I'm going to change this now to the cosecant squared of 3x dx. Now I'm going to integrate that. Well, I don't know what the antiderivative of cosecant squared is, so I'm going to have to use, well, I know what the of cosecant squared is, the integral of that is, but I don't know about when the 3x is there. So I'll let u equal 3x and see if magic happens. And this is basically how you got to do it. You just got to play with it and try something and hope that it works. Like I said, it's like when you first learn to factor. So derivative of that is du 3 dx. So dx will equal divided by 3 1/3 du. Plug that in. So I have 1/3 cosecant squared of u du. And I can integrate that. Remember what the integral of cosecant squared. Oops. That probably sounded weird, but if you could see my face, you would know that I was about to sneeze and fought it off. So, let's see, what was I talking about? Oh yeah, cosecant squared. You remember what that is the derivative of? If not, you should remember the old thing. SST, where this was secant, tangent, with the arrows, and on the bottom you put the opposites, so cosecant, this one had a negative, cosecant, cotangent. So right here, derivative of cotangent is negative cosecant squared, so there we go. So the antiderivative of cosecant squared, I'm going to need negative cotangent, and I got a 1/3 in there, so I'll just leave that there, negative 1/3 of the cotangent of u pu. Now just plug u in. Oh, almost forgot the old plus c. Plug the u in, so that's negative 1/3 cotangent of 3x. Oops, I don't know why I wrote u. I should have plus c. I'm not feeling it right now, so there's that. Play with these. You get the rest of the period. I'm going to give you something to work on. Don't sit there and mess around on your phone and try to think you're going to go home and do this at 9:30 tonight, because I guarantee you that will not happen. You will fail horribly at that. Here you go. I had a lot of them written down, but I think I'll shorten it to just 6. I had 10, but I want you to spend more time on these, so when you get it wrong once, you do it again, and when you get it wrong again, you do it again, and then hopefully by the 3rd or 4th time, you'll get it figured out. So there it is. I know this is hard, but good luck, and I'll see you tomorrow, and we will do this some more. Oh, and Rachel, I threw your Cheez-Its away, sorry. I didn't know if you were leaving them there for today. Alright.